What if I told you that most data science teams don't have a strategy at all? They have plans, roadmaps, and backlogs. But these aren't strategies. They're just lists of activities without a guiding principle. In this video, I'm going to share the exact framework I use to build successful data science strategies for teams ranging from 3 people at a startup to 50 plus at a Fortune 500 company. You'll learn how to create a strategy that focuses your team's efforts and drives measurable business impact. The one-sentence definition that changes everything. What if most data science leaders are getting strategy completely wrong? I've consulted with dozens of teams across industries, and almost every time I ask to see their data science strategy, they proudly present me with a list. Sometimes it's a list of projects they plan to complete. Other times it's technologies they intend to implement. Occasionally it's hiring plans or organizational structures. But here's the problem. None of these things constitute a strategy. This misconception isn't unique to data science. Organizations everywhere confuse plans with strategy. The difference might seem semantic, but it creates profound consequences for data teams trying to deliver value. When we treat strategy as merely a roadmap of activities, we fail to address the fundamental question that should guide our work. How will we behave to create competitive advantage? Consider a financial services company I worked with last year. Their data science strategy was a detailed 18-month plan listing predictive models they would build, a data lake implementation timeline, and hiring targets for specific technical roles. 6 months in, market conditions shifted dramatically, and customer needs changed. Their beautifully crafted plan became irrelevant almost overnight. Without guiding principles for behavior, the team floundered, chasing new priorities while abandoning half-completed initiatives. In another case, a healthcare analytics team spent months creating what they called a comprehensive data strategy. The document outlined specific tools, methodologies, and projects, all tactical components without a unifying strategic direction. When leadership changed, the new executive questioned these choices. Without clear behavioral commitments tied to competitive advantage, the team couldn't defend their approach. The result? Resources were redirected, team morale collapsed, and months of work went to waste. These examples reflect what happens when we mistake activity for strategy. The plans themselves weren't necessarily bad, they were just insufficient. They answered what, without addressing how or why. They focused on tasks rather than behavioral patterns that would differentiate the team and create value regardless of changing circumstances. This brings us to the definition that transformed my own understanding of strategy. Gary Pisano, in his work on R&D strategy, offers this powerful insight. A strategy is nothing more than a commitment to a pattern of behavior intended to help win a competition. This elegant formulation cuts through the confusion and provides clarity about what strategy actually is. Let's break this down for data science teams specifically. First, strategy is a commitment to a pattern of behavior. It's not about specific projects or technologies. Those are tactical choices that should flow from your strategy. Instead, it's about how your team consistently acts and makes decisions. Will you prioritize speed over perfection? Will you focus on specialized expertise or versatile capabilities? Will you develop proprietary methods or leverage open source solutions? These behavioral patterns, consistently applied, define your strategy. Second, this behavior is intended to help win a competition. Data science doesn't exist in a vacuum. Your team competes for resources within your organization, for talent in the marketplace, and ultimately to create value that helps your company outperform competitors. A true strategy acknowledges this competitive context and makes explicit choices about where and how to compete. For data science leaders, this definition is transformative because it shifts focus from project deliverables to the decision-making frameworks that guide all activities. When market conditions change or new technologies emerge, a project list quickly becomes obsolete. But behavioral commitments can remain consistent even as tactical execution evolves. Take a retail analytics team I advised that completely reimagined their approach using this definition. Instead of listing dashboard projects and machine learning models, they committed to behavioral patterns. They would prioritize customer-facing improvements over internal efficiencies, favor rapid experimentation over lengthy perfectionism, and emphasize business intelligible algorithms over black box solutions. These commitments didn't specify what they would build, but they created clear guidelines for how they would operate in any circumstance. When retail shopping patterns drastically changed during the pandemic, teams operating from project plans scrambled to adjust. But this team's behavioral strategy provided immediate guidance on how to respond. Their commitment to customer-facing improvements meant quickly shifting to new purchasing patterns. Their rapid experimentation approach allowed them to test and learn in uncertain conditions. Their focus on intelligible algorithms meant business partners could understand and trust their evolving recommendations. This strategic approach changes everything about how data science teams operate. Instead of asking, what projects should we work on next quarter? It prompts more fundamental questions. How should we behave to create maximum competitive advantage? What patterns of decision-making will consistently lead to success regardless of specific projects? The transformation extends to how teams evaluate success. Rather than measuring progress against a project timeline, which rewards activity but not necessarily impact, they assess whether their behavioral patterns are creating the intended competitive advantage. Are they making decisions faster than competitors? Are they connecting with customers more effectively? Are they generating insights that others miss? For team members, this definition provides clarity and autonomy. When everyone understands the behavioral patterns that define the strategy, they can make consistent decisions without constant supervision. They know how to prioritize when competing demands arise and can adapt to changing circumstances while remaining strategically aligned. This shift in thinking from projects to behaviors, from activities to competitive advantage isn't merely theoretical. It's the difference between data science teams that consistently deliver value and those that struggle to justify their existence when conditions change. The power of this definition becomes especially evident during organizational transitions. When leadership changes or budgets tighten, teams without a true strategy find their work suddenly questioned or redirected. Teams with clear behavioral commitments tied to competitive advantage can articulate their value regardless of who's in charge. This doesn't mean you should abandon planning altogether. Tactical plans remain important for execution, but they should derive from your strategic behavioral commitments rather than constitute the strategy itself. The projects you pursue should be expressions of your strategic behaviors, not the strategy itself. So, what is the one-sentence definition of strategy that changes everything? It's that a strategy is a commitment to a pattern of behavior intended to win a competition, not just a plan or roadmap. This definition liberates data science teams from the tyranny of project lists that quickly become outdated and focuses attention on the consistent behaviors that create lasting competitive advantage. Plans versus strategy, the critical difference. If strategy is about behavioral commitments rather than project lists, why do 85% of data science teams still confuse the two? The distinction isn't just academic, it's the difference between teams that create lasting value and those that constantly restart from zero. When data science leaders proudly slide documents across the table labeled "Our Data Strategy," I often find myself looking at elaborate spreadsheets listing technologies to implement, dashboards to build, or models to deploy over the next 12 to 18 months. These documents typically follow a predictable pattern. They begin with current state assessment, move to gap analysis, then outline a series of projects with timelines, resource requirements, and sometimes even ROI calculations. At first glance, these documents appear comprehensive. They contain Gantt charts showing implementation phases for data lakes, machine learning platforms, or analytics tools. They outline hiring plans for specific roles, data engineers, ML engineers, business analysts. They specify which algorithms will be deployed and which business units will receive analytics capabilities first. They're often visually impressive, with professional graphics and executive summaries designed for leadership consumption. The problem isn't that these documents lack detail or thought. The problem is that they answer an entirely different question than what strategy should address. They explain what the team plans to do, but not how they'll behave differently to outperform competitors or create sustainable advantage. Let me illustrate this distinction with a concrete example. Imagine two retail companies facing the same challenge: improving customer retention through data science. The first company develops what they call a strategy that lists projects. Implement a customer data platform in Q1, build churn prediction models in Q2, develop recommendation engines in Q3, and deploy personalized marketing campaigns in Q4. The second company takes a different approach. Their strategy states, "We will win by rapidly testing small targeted interventions based on simple customer behavior patterns rather than building comprehensive models. We commit to running at least 5 small experiments per month, making decisions within 48 hours of getting results, and scaling successful approaches immediately, even with incomplete information." When market conditions change, say a major competitor launches an innovative loyalty program, the responses reveal the critical difference. The first company's detailed plan becomes obsolete. They must restart their planning cycle, reevaluate priorities, and develop a new project sequence. Meanwhile, the second company simply applies their established behavioral pattern to the new situation, quickly testing counter moves and scaling what works. This distinction becomes even more critical as data science teams grow. A startup with 3 data scientists might survive with just a plan because informal communication and rapid pivoting happen naturally. But as teams grow to 10, 30, or 100 people across multiple business units, the lack of consistent behavioral commitments leads to fragmentation. Without clear strategic behaviors, different team members make conflicting decisions, pursue contradictory approaches, and optimize for incompatible outcomes. In enterprises, I've witnessed teams with impressive technical talent who produced minimal business impact because they lacked strategic behavioral commitments. Their strategy documents outlined ambitious roadmaps for advanced AI capabilities, but said nothing about how decisions would be made, which problems would take priority, or what trade-offs would guide their work. The result was a collection of technically impressive but disconnected initiatives that failed to build on each other or create lasting competitive advantage. What we're witnessing is the fundamental nature of plans versus strategies. Plans specify tasks, timelines, and deliverables. They answer what and when questions. They are necessary operational documents, but they don't provide guidance for how to respond to changing circumstances or how to make difficult trade-offs. They become outdated the moment market conditions shift. Strategies, by contrast, specify behavioral patterns and decision criteria. They answer how questions. How will we make decisions? How will we allocate resources? How will we approach problems differently than our competitors? These behavioral commitments provide consistent guidance, even as specific projects evolve. Another critical difference emerges in how success is measured. Plans are evaluated based on completion metrics. Did we finish the projects on time and within budget? Strategies are evaluated based on competitive outcomes. Did our behavioral patterns create advantage compared to alternative approaches? This distinction forces teams to connect their work directly to competitive position rather than just checking boxes on a project list. The confusion between plans and strategies creates particular problems for data science because of the field's inherent uncertainty. In established functions like finance or operations, detailed plans often work because the environment is relatively stable and processes are well understood. But data science involves exploration, experimentation, and discovery. Detailed project plans for such work invariably become fiction shortly after they are created. This reality doesn't mean data science teams should abandon planning. Rather, it means their strategies must establish behavioral patterns specifically designed to navigate uncertainty effectively. These might include commitments to specific experimentation cadences, explicit resource allocation between exploration and exploitation, or decision processes for rapidly terminating unproductive avenues. One multinational consumer goods company I worked with transformed their approach when they shifted from a detailed AI implementation roadmap to a strategy focused on rapid learning cycles. Their new strategy committed to specific behaviors. All initiatives would start with minimum viable data products delivered in under 4 weeks. Business stakeholders would be embedded in technical teams rather than just receiving updates. And technical complexity would be deliberately limited until business value was validated. These behavioral commitments remained constant, even as specific projects evolved dramatically based on market feedback. The root of this confusion often lies in how requests for strategy are framed within organizations. When an executive asks a data science leader to develop our data strategy, both parties frequently default to thinking about roadmaps and implementation plans because these are concrete and familiar formats. Breaking this pattern requires explicitly reframing the request around behavioral commitments and competitive approaches rather than project sequences. As teams grow in size and complexity, the distinction between plans and strategies becomes even more crucial. Small teams might succeed through the intuitive behaviors of a few talented individuals, but larger teams require explicit behavioral commitments to maintain coherence. Without them, different team members optimize for incompatible outcomes, technical decisions lack consistency, and the cumulative effect of the team's work diminishes rather than compounds. The 3 requirements of effective strategy. Beyond mere behavioral patterns lies a more fundamental challenge: crafting a strategy that actually works when implemented. What makes the difference between data science strategies that drive organizational transformation versus those that become irrelevant within months? 3 specific requirements separate success from failure. In all my years consulting with data science teams, I've witnessed a recurring pattern. A brilliant team develops what appears to be a compelling strategy. They've correctly identified that strategy is about behavioral commitments rather than project lists. Their document beautifully articulates how they'll behave to create competitive advantage. Everyone nods enthusiastically at the kickoff meeting, yet 6 months later, the strategy has been abandoned, or worse, is being followed religiously despite producing minimal results. Gary Pisano's research on R&D strategy goes beyond simply defining strategy as behavioral commitments. He identifies 3 critical requirements that separate theoretical strategies from those that actually transform organizations: consistency, coherence, and alignment. When data science strategies fail, despite correct intentions, it's typically because they've missed one or more of these fundamental requirements. Let's examine each requirement and understand why they matter specifically for data science teams. Consistency refers to making decisions that contribute to the same competitive advantage over time. This doesn't mean rigidly sticking to the same tactics regardless of circumstances, but rather ensuring that the underlying behavioral patterns reinforce the same strategic goals, even as implementation details evolve. Consider a financial technology startup I advised whose strategy emphasized rapid experimentation to discover customer needs. Their behavioral commitment was to conduct at least 2 customer experiments weekly. Initially, this worked brilliantly, but when they received a large investment, the leadership suddenly shifted focus to building enterprise-grade infrastructure that would take months to implement with no customer feedback. While they claimed their strategy remained unchanged, their actual decisions no longer reflected their stated behavioral commitments. Within 3 months, they had built sophisticated systems that customers didn't want, forcing them to start over with substantial sunk costs. The lesson? Consistency doesn't mean inflexibility, but it does require discipline to maintain core behavioral commitments even when tempting alternatives arise. For data science teams, consistency is particularly challenging because opportunities constantly emerge to apply new technologies or methodologies that may distract from strategic focus. The second requirement, coherence, means ensuring all parts of your strategy support rather than contradict each other. Many data science strategies include behavioral commitments that sound reasonable individually but create friction when combined. A pharmaceutical research team I worked with committed both to maintaining gold standard data quality and rapidly prototyping analytics models. In practice, these commitments created constant conflict as the rigorous data preparation processes made rapid prototyping impossible. Team members split into camps, with data engineers prioritizing quality and data scientists prioritizing speed. The resulting tension paralyzed decision-making. Creating coherence means critically examining how your behavioral commitments interact with each other. Do they create synergies, or do they pull your team in different directions? This requires honestly assessing trade-offs rather than pretending contradictions don't exist. The pharmaceutical team eventually revised their strategy to focus on fit-for-purpose data quality, maintaining rigorous standards for production systems while accepting approximations for early-stage experimentation. This single adjustment created coherence that allowed both rapid innovation and reliable production systems. The third requirement, alignment, connects your strategy to broader organizational goals and competitive context. Even the most consistent and coherent data science strategy fails if it doesn't help the organization win in its specific competitive environment. A retail analytics team I worked with had developed a beautifully coherent strategy focused on sophisticated customer lifetime value modeling. Their behavioral commitments all supported this focus consistently. The problem? Their organization competed primarily on supply chain efficiency, not customer intimacy. While their strategy was internally sound, it lacked alignment with organizational priorities. Creating alignment requires understanding how your team's distinctive capabilities contribute to your organization's competitive position. This means regularly reassessing whether your behavioral commitments still serve the organization's evolving needs. The retail analytics team ultimately revised their strategy to focus on inventory optimization and demand forecasting, creating immediate value recognition from leadership. These three requirements become exponentially more difficult to maintain as data science teams scale. With a team of three, consistency often emerges naturally through daily interactions. With 30 team members spread across different projects and locations, maintaining consistency requires deliberate communication and governance structures. A global insurance company I advised struggled with this exact challenge. Their data science strategy appeared sound on paper, but regional teams interpreted and implemented behavioral commitments differently based on local conditions. The result was fragmentation rather than collective impact. Similarly, coherence becomes more challenging as teams grow because different subgroups naturally optimize for different outcomes based on their specific responsibilities. Alignment becomes more complex as teams must interface with more stakeholders holding divergent priorities. The structured governance that helps larger teams maintain consistency can sometimes hinder the flexibility needed for alignment with changing organizational needs. When data science strategies fail, despite being focused on behavioral commitments rather than project lists, the root cause typically traces back to missing one of these three requirements. A technology company I worked with committed to democratizing data access by building self-service tools for all departments. This behavioral commitment was clear and consistently followed, but lacked coherence with their other commitment to protecting sensitive customer information. The result was constant security exceptions, duplicated efforts to build department-specific solutions with varying controls, and frustrated stakeholders. Another common failure pattern is when teams maintain consistency and coherence but lose alignment over time. An energy sector analytics team followed their strategy of building advanced predictive maintenance models with impressive discipline. Their behavioral commitments were consistent and coherent. However, when market pressures shifted their company's focus to renewable energy initiatives, they continued optimizing traditional operations while the organization pivoted around them. Despite executing their strategy flawlessly, they became increasingly irrelevant to business outcomes. Testing your data science strategy against these three requirements provides a powerful way to identify potential failure points before they manifest. Ask yourself, will these behavioral commitments still apply when conditions change? Consistency. Do these commitments support or contradict each other? Coherence. And do these commitments help the organization win in its competitive context? Alignment. Why data science teams struggle with strategy. Testing your data science strategy against these requirements reveals an uncomfortable truth. Data science teams operate in organizational territory where consistency, coherence, and alignment are uniquely difficult to maintain. What if the very nature of data science work itself, not poor leadership or unclear vision, is what makes strategic success so elusive? Data science occupies a peculiar position in most organizations. Unlike marketing, sales, or even traditional IT, data teams sit at a complex intersection. They're highly technical specialists who must simultaneously translate abstract concepts into business value. This hybrid identity creates an organizational limbo where data teams are expected to be both innovative researchers and reliable service providers, often to multiple stakeholders with competing priorities. This positioning creates strategic quicksand that few leaders are prepared to navigate. Consider how data science must bridge multiple worlds. They need deep technical expertise to implement solutions, business domain knowledge to identify valuable problems, and political savvy to navigate organizational priorities. Each of these domains operates on different timescales and success metrics, making consistent behavioral commitments extraordinarily difficult. The technological foundation of data science brings its own strategic complications. While marketing strategies might remain stable for years, data science teams face a landscape where foundational tools and techniques evolve quarterly. A commitment to specific technologies, whether database architectures, programming frameworks, or model architectures, risks becoming obsolete before the strategy can even be fully implemented. What other department faces a situation where their primary tools might be rendered outdated by a single research paper or open source release? Take the experience of a mid-sized insurance company that committed to a strategy centered around traditional machine learning models. 6 months into implementation, advances in transformer-based architectures made their approach significantly less competitive. Their commitment to a specific technical approach, rather than to the behavioral pattern of continuously evaluating emerging methods, left them scrambling to catch up while competitors surged ahead. Beyond the technical flux, data science teams face unique challenges in maintaining coherence across their strategic commitments. Their cross-functional nature means they often serve as the connective tissue between departments with fundamentally different perspectives and incentives. Product teams want quick experiments to validate features. Finance needs reliable forecasting models. Operations demands efficient optimization algorithms. And executives request comprehensive dashboards, all from the same team working with the same finite resources. A healthcare analytics startup illustrated this challenge perfectly when they attempted to simultaneously commit to rapid experimentation for clinical products while also promising enterprise-grade reliability for their patient management systems. These behavioral commitments directly contradicted each other in practice, creating impossible situations where team members couldn't satisfy both strategic directions simultaneously. When pushed to prioritize, leadership would often give conflicting guidance depending on which stakeholder had most recently raised concerns. The alignment challenge for data science stems from its relatively novel position in organizational hierarchies. While established departments like finance or sales have clearly defined relationships to business outcomes, data science's contribution can be more difficult to quantify and communicate. This creates an alignment gap where data teams might technically deliver on their behavioral commitments while still failing to connect those behaviors to competitive advantage. A telecommunications provider exemplified this struggle when their data science team perfectly executed on their strategic commitment to develop sophisticated customer segmentation models. The models were technically impressive, statistically sound, and delivered on schedule. However, because the team hadn't aligned their strategy with the organization's primary competitive challenge, reducing network infrastructure costs, the sophisticated segmentation work generated minimal business value despite being a technical success. For smaller data science teams, these strategic challenges often manifest as whiplash-inducing priority shifts. A 3-person data team at a logistics startup found themselves ricocheting between commitments to build predictive maintenance capabilities and enhance customer-facing analytics, because different executives had different visions of how data science should create value. Without a consistent strategic direction that the organization had collectively endorsed, the team's behavior became reactive rather than strategic. At the enterprise scale, these challenges can create strategic fragmentation. A global manufacturing company with data scientists embedded across multiple business units discovered that each team had developed different and sometimes contradictory behavioral commitments. Some prioritized algorithmic sophistication, others focused on stakeholder partnership, and still others emphasized production engineering excellence. When these teams needed to collaborate on cross-functional initiatives, these different behavioral patterns created significant friction and inefficiency. The experimental nature of data science work amplifies these strategic difficulties. Unlike departments with predictable workflows and outcomes, data teams engage in work with inherently uncertain results. Models may not achieve expected accuracy. Data quality issues might emerge midway through projects, or analysis might reveal that initial assumptions were incorrect. This uncertainty makes it challenging to establish consistent behavioral patterns when the work itself requires adaptation and course correction. A digital native retail company committed to a behavioral pattern of delivering model updates weekly, but found this commitment impossible to maintain because some models required extensive retraining and validation before deployment. Their technical reality conflicted with their strategic commitment, creating tension between quality and consistency. Only when they refined their strategy to commit to regular risk-appropriate update cycles could they establish a sustainable pattern that accommodated the inherent uncertainty in their work. Additionally, data science teams face the challenge of balancing exploration, discovering new insights and approaches, with exploitation, delivering reliable value from established methods. This dual mandate creates strategic tension that few other departments face so acutely. Marketing might test new channels, but data science must often simultaneously explore entirely new methodologies while delivering consistent results from existing ones. A financial services analytics team tried to resolve this tension by assigning different team members to either innovation or production work, only to discover that this created knowledge silos and inconsistent outputs. Their revised strategy committed instead to a behavior of time-boxed exploration within production cycles, allowing all team members to participate in both modes while maintaining coherent delivery patterns. These strategic challenges aren't signs of failure. They're inherent to the position data science occupies in modern organizations. The teams that succeed strategically recognize these unique difficulties and craft strategies that explicitly account for them rather than struggling against them. Learning from R&D, strategic lessons for data science. The strategic difficulties facing data science aren't unique in the corporate landscape. They're remarkably similar to challenges that R&D departments have been solving since the 1950s. Yet most data leaders overlook this valuable source of strategic wisdom, attempting to build frameworks from scratch rather than adapting proven approaches. When we examine the function of research and development departments across industries, the parallels with data science become striking. Both operate at the intersection of discovery and practical application. Both face uncertain outcomes and timelines. Both must balance deep technical expertise with business relevance. And perhaps most importantly, both must deliver innovation while maintaining enough predictability to satisfy organizational demands. This similarity isn't merely superficial. The strategic frameworks that have guided R&D departments through decades of technological revolution offer ready-made solutions to many of the unique challenges data science teams face today. Corporate R&D departments pioneered approaches to managing innovation portfolios long before data science entered our vocabulary. Consider how mature R&D organizations approach portfolio management. They don't view projects as independent initiatives, but as a deliberately balanced collection designed to distribute risk while maximizing potential returns. A typical R&D portfolio might allocate approximately 70% of resources toward incremental improvements to existing products, 20% toward adjacent innovations that extend into new markets or technologies, and 10% toward transformational moonshots that could fundamentally reshape the business. One pharmaceutical data science organization that adopted this R&D-inspired approach transformed their strategic approach completely. Rather than evaluating each potential project in isolation, they classified initiatives as incremental, improving existing analytical models, adjacent, applying proven techniques to new business domains, or transformational, exploring cutting-edge AI methodologies with uncertain but potentially massive returns. This portfolio view allowed them to maintain a healthy innovation pipeline while still delivering predictable short-term value, precisely the balance many data science teams struggle to achieve. Another core R&D strategic principle involves deliberately structuring time horizons. Unlike many corporate functions that operate primarily on quarterly cycles, sophisticated R&D organizations simultaneously manage initiatives across multiple time horizons, from immediate tactical improvements to decade-long fundamental research. This multi-horizon approach helps organizations avoid the common trap of sacrificing long-term innovation for short-term deliverables. A financial services data science team incorporated this principle by establishing 3 parallel work streams with different time horizons. One team focused on immediate analytical needs with 2-week delivery cycles. A second team tackled medium-term innovations with quarterly objectives. A third small team explored emerging technologies and methodologies with annual goals and lightweight accountability structures. Rather than competing for resources, these teams operated as a coherent ecosystem, each reinforcing the other's work while delivering value across different timescales. R&D organizations have also mastered the art of risk balancing through their strategic approaches. They recognize that innovation inherently involves failure, but they make this palatable to the broader organization by structuring how and when those failures occur. Early-stage ideas face rigorous but appropriate testing designed to quickly eliminate non-viable concepts before significant investment occurs. As concepts prove themselves, they receive progressively more resources and increasingly stringent evaluation. A technology company's data science division applied this staged funding approach to their predictive modeling initiatives. Initial concepts received minimal resources, but faced weekly viability checks. Models that demonstrated promise graduated to more substantial funding with monthly evaluation cycles. Only proven approaches that cleared these hurdles received full production implementation resources. This staged approach allowed the team to explore dozens of potential innovations while focusing substantial resources only on approaches with demonstrated potential, a dramatic improvement over their previous all-or-nothing funding model. Perhaps the most valuable strategic framework that data science can borrow from R&D involves how these departments handle the fundamental tension between exploration and exploitation. R&D leaders understand that organizations need both breakthrough innovations and continuous improvements to existing offerings. Rather than treating this as a binary choice, sophisticated R&D departments create structural solutions that accommodate both needs. A healthcare analytics organization that adopted this principle created distinct teams with different behavioral commitments. Their exploration team operated with greater autonomy, longer time horizons, and acceptance of higher failure rates. Their exploitation team focused on refining and scaling proven approaches with more structured processes and delivery expectations. Critically, they established deliberate transfer mechanisms between these teams, ensuring successful explorations eventually became reliable exploitations. R&D departments have also pioneered approaches to measuring outcomes under uncertainty, another challenge that plagues data science teams. Rather than attempting to predict precise ROI for innovative initiatives, mature R&D organizations establish learning objectives and progress metrics that acknowledge the inherent uncertainty of discovery work. A manufacturing company's data science team shifted from attempting to quantify exact financial returns for early-stage machine learning initiatives to measuring learning velocity and knowledge acquisition. For projects in the discovery phase, success metrics included hypothesis validation rates, dataset quality improvements, and reduction in predictive errors, not direct business outcomes. As initiatives matured, measurement shifted toward operational metrics and ultimately financial impact. This staged measurement approach aligned perfectly with the inherent uncertainty of data innovation. The strategic sophistication of R&D extends to how these departments handle their talent. They recognize that innovation requires different skills and working styles than optimization, and they structure roles accordingly. Some R&D staff excel at exploratory research, while others specialize in translating discoveries into practical applications. A retail data science team applied this principle by creating differentiated roles that acknowledge these distinct skill sets. Some data scientists focused on experimental applications and novel analytical approaches, while others specialized in hardening promising techniques into reliable production-grade solutions. By recognizing these as complementary rather than competing approaches, they created career paths that valued both innovation and implementation expertise. What makes these R&D strategic approaches so valuable to data science is how directly they address the unique challenges we identified earlier. The portfolio approach provides a framework for maintaining consistency across diverse initiatives. Multi-horizon planning offers a path to coherence when balancing short and long-term objectives. And the structured approach to exploration and exploitation helps maintain alignment between innovative impulses and organizational needs. Best of all, these strategic approaches come with decades of refinement and practical validation across industries. Data science leaders don't need to invent strategic frameworks from scratch. They can adapt proven approaches from a discipline that has faced similar challenges for generations. Applying strategy to AI and ML teams. Adapting proven frameworks is essential, but what happens when your team ventures into the uncharted territory of artificial intelligence? Despite borrowing strategic wisdom from R&D, I discovered through painful experience that AI and ML teams face unique challenges that require fundamentally different behavioral commitments than other data disciplines. My first leadership role over an AI team taught me this lesson the hard way. We had implemented a data science strategy that worked brilliantly for our analytics projects, clear timelines, defined deliverables, and structured evaluation metrics. But when we applied the same approach to our machine learning initiatives, we hit unexpected roadblocks that no amount of planning could solve. The core issue became evident. AI and machine learning work operates under fundamentally different conditions than traditional analytics. The uncertainty isn't just a factor, it's the dominant condition. While analytics teams can often predict how long it will take to extract insights from existing data, AI teams are navigating a landscape where the very feasibility of a solution might remain unknown until significant resources have been invested. This unpredictability stems from three characteristics unique to AI/ML work. First, the search space for solutions is exponentially larger, with countless architectural decisions, hyperparameter configurations, and data transformations that might unlock performance breakthroughs. Second, the relationship between input and output is often non-linear. Small changes can produce dramatic improvements or failures with little warning. Third, the infrastructure requirements evolve rapidly, sometimes necessitating complete rebuilds of systems that worked perfectly just months earlier. A strategy designed for business intelligence or even traditional statistical modeling simply doesn't accommodate these realities. It's like trying to use a roadmap for ocean navigation. The tools and assumptions fundamentally don't match the territory. Consider what happened at a computer vision startup I consulted for. Their initial strategy emphasized consistent weekly progress demonstrations to investors. This worked perfectly for their dashboard and analytics features, but created immense pressure on their object detection team, who experienced weeks of seemingly no progress, followed by sudden breakthroughs. The weekly demonstration cadence pushed the team toward incremental improvements to show something, rather than the exploratory work needed for significant advances. The solution was a complete strategic reframing. Rather than committing to weekly visual progress, they shifted to a behavioral pattern of maintaining comprehensive experiment logs and weekly research reviews focused on learning rather than results. This single strategic shift transformed their team's performance, ultimately leading to a technical breakthrough that became their core competitive advantage. This experience highlights why AI and ML teams need unique behavioral commitments. While an analytics team might thrive with a strategy centered on rapid iteration with stakeholders, ML teams often need extended periods of technical exploration before stakeholder involvement becomes valuable. The strategic behaviors that create competitive advantage differ significantly. Successful AI and ML strategies typically include specific behavioral commitments in four key areas. First, experimentation cadence, how teams structure their learning loops. One enterprise AI team I worked with committed to running at least 20 architecture experiments weekly while documenting results in a standardized format. This seemingly simple behavior created an invaluable knowledge repository that accelerated their progress significantly compared to competitors. Second, knowledge distribution patterns, how insights flow between team members. A natural language processing startup adopted a behavioral commitment to pair programming for all model development work, despite the apparent inefficiency. This strategic behavior resulted in dramatically reduced knowledge silos and more robust architecture decisions that competitors couldn't match. Third, failure tolerance frameworks, how teams respond when approaches don't work. One autonomous systems team committed to celebrating valuable failures with formal recognition for experiments that disproved promising hypotheses, saving future resources. This behavioral commitment transformed how they approached risk and accelerated their overall progress. Fourth, deployment bridges, how research insights transition to production systems. A healthcare AI team implemented a model shadowing period where new algorithms ran parallel to existing systems for extended evaluation before taking control. This strategic behavior built trust with clinical partners and enabled more aggressive innovation than competitors who faced resistance to implementation. These strategic behaviors contrast sharply with those that work for analytics teams. Where analytics teams might commit to business value in every sprint, ML teams often need behavioral commitments like exploring at least 3 novel approaches before optimization. Analytics teams can often commit to fixed delivery dates, while ML teams need flexible development cycles with rigorous evaluation gates. The contrast becomes even more apparent in how these teams approach stakeholder relationships. A financial services AI team I advised struggled until they shifted from the analytics-inspired behavior of demonstrating incremental progress to stakeholders biweekly to educating stakeholders on research processes and establishing quarterly evaluation points. This strategic shift created the space they needed for meaningful exploration while maintaining organizational trust. Another critical difference appears in technical debt management. Traditional analytics teams can often defer maintenance work in favor of new features. For ML teams, algorithm maintenance is existential. Models degrade as the world changes. A retail recommendation engine team committed to allocating 30% of resources to continuous evaluation and retraining, which competitors viewed as inefficient. This strategic behavior ultimately proved decisive when market patterns shifted during the pandemic and their models adapted while competitors failed. The distinction extends to talent development too. A computer vision team at a manufacturing company struggled until they revised their strategy to include a behavioral commitment of dedicating 20% of senior researchers' time to internal knowledge transfer. This apparently costly behavior became their competitive advantage as they could rapidly train new team members while competitors fought over a limited pool of experienced specialists. The research production tension requires particularly careful strategic navigation. One autonomous vehicle company committed to maintaining parallel research and production implementations of key systems with explicit processes for migrating innovations between them. This behavioral pattern allowed them to simultaneously pursue cutting-edge research while maintaining reliable production systems, a balance many competitors failed to achieve. Even the approach to failure requires different strategic behaviors. An NLP startup adopted a bounty system for identifying failure modes in production models with dedicated time allocations for addressing discoveries. This strategic behavior created resilient systems that outperformed more academically advanced competitors whose models failed in unexpected real-world conditions. These examples demonstrate why applying general data science strategies to AI and ML teams frequently fails. The unique characteristics of machine learning work, its exploration-heavy nature, non-linear progress patterns, and complex deployment challenges require tailored strategic approaches focused on specific behavioral commitments. The common strategy mistake leaders make. Behavioral patterns that drive AI success highlight the critical difference between planning and strategy, a distinction most leaders miss entirely. What if the reason most data science strategies fail isn't about execution at all, but stems from a fundamental misunderstanding that happens the moment an executive makes the request? Picture this scenario. A VP calls you into their office and says, "We need a data science strategy for our organization. Can you have something on my desk by the end of the month?" You nod confidently, but as you walk away, a wave of uncertainty hits. What exactly are they asking for? With limited guidance, most leaders default to creating what they believe executives want to see: detailed timelines, technology selections, and project roadmaps. This scenario plays out thousands of times across organizations worldwide, and it triggers the most common and damaging mistake in data science leadership: misinterpreting the request for strategy as a request for a comprehensive plan of activities. The distinction might seem subtle, but the consequences are profound. When executives request a data science strategy, they typically expect a document that bears little resemblance to what would actually help the team succeed. They anticipate receiving an impressive slide deck filled with timelines for implementing specific technologies, forecasts of resource requirements, and promises of specific deliverables. What they should receive instead is a clear articulation of how the team will behave differently from competitors to create sustainable advantage. I witnessed this mistake firsthand at a major telecommunications company where the newly appointed chief data officer spent 3 months developing what he called a comprehensive data science strategy. The impressive 60-page document detailed every project the team would undertake over the next 2 years, the technologies they would implement, and the projected ROI for each initiative. Leadership approved it enthusiastically, and the team began execution immediately. 6 months later, the strategy was effectively abandoned. Market conditions had shifted, executive priorities had changed, and several key technologies mentioned in the document had been superseded by newer alternatives. The document provided no guidance on how to adapt because it had focused entirely on what the team would do, rather than how they would make decisions and behave to create advantage. This contrasts sharply with a mid-size insurance company whose data science leader took a different approach. When asked for a strategy, she delivered a concise 5-page document that barely mentioned specific projects or technologies. Instead, it articulated clear behavioral commitments, how they would evaluate investment opportunities, their approach to balancing exploratory versus exploitative work, and their decision criteria for pursuing or abandoning initiatives. When market conditions shifted, this team adapted their project portfolio while maintaining consistent decision-making patterns that continued to create advantage. The mistake stems from a fundamental misconception of what constitutes strategy. Most data science leaders, especially those without formal strategy training, equate strategy with detailed planning. They believe that the more comprehensive and specific their plan, the more strategic it appears. This leads to documents that impress initially, but provide minimal actual strategic guidance. A strategic approach would instead focus on questions like, what types of problems will we prioritize? How will we decide between competing opportunities? What criteria will guide our investment decisions? How frequently will we evaluate results and pivot? How will we balance immediate needs against long-term capability building? At an e-commerce company I consulted with, the data science director initially presented a strategy that specified implementing a customer segmentation model in Q1, developing a recommendation engine in Q2, and launching personalized marketing automation in Q3. When asked how these activities would create advantage relative to competitors who were pursuing similar projects, he struggled to answer. The revised strategy shifted focus to behavioral commitments, running twice as many customer experiments as competitors, making go, no-go decisions within 1 week of results, and maintaining a consistent 30% of resources dedicated to platform improvements rather than immediate applications. This strategy proved resilient through multiple business cycles and leadership changes because it focused on how the team would behave rather than specific deliverables. 2 years later, not a single project from the original plan remained unchanged, but the behavioral patterns continued to generate competitive advantage. The mistake becomes increasingly damaging as organizations grow and contexts evolve. A small team might temporarily succeed with a project-focused approach due to tight communication and shared implicit understanding. But as teams expand, the absence of clear behavioral commitments leads to inconsistent decision-making, resource allocation conflicts, and strategic drift. A global financial services firm experienced this firsthand as their data science function grew from 15 to over 100 professionals in 18 months. The original strategy document focused on specific analytical models and technology implementations, provided no guidance on how to prioritize competing requests or balance innovation against reliability. By the time they realized the issue, they had dozens of disconnected initiatives with no coherent pattern of behavior, resulting in organizational frustration and wasted investment. Reframing the request for a data science strategy can fundamentally change outcomes. When an executive asks for a strategy, skilled leaders clarify whether they're seeking a plan of activities or a definition of how the team will behave to create advantage. This simple clarification often surprises executives who haven't considered the distinction, opening the door for a more meaningful strategic conversation. The healthcare analytics leader handled this effectively when asked for a strategy by the CFO. Instead of immediately producing a document, she scheduled a discussion to understand what competitive challenges the organization faced and how data science could contribute to addressing them. This conversation revealed that the CFO was primarily concerned with improving operational efficiency rather than developing cutting-edge analytical capabilities. Armed with this insight, she developed a strategy focused on behavioral commitments around rapid implementation of proven analytical techniques rather than exploration of novel approaches. A pattern of behavior specifically designed to address the organization's actual competitive needs. This approach shifts the strategic focus from what we will build to how we will behave to win. It transforms the conversation from project selection to capability building. Rather than committing to specific outputs that may become irrelevant. It commits to decision patterns and behaviors that remain valuable regardless of how specific projects evolve. The most effective data science strategies I've seen have been remarkably brief in terms of specific project commitments, but crystal clear about behavioral patterns. One particularly successful example came from a manufacturing company whose entire data science strategy could be summarized in 3 behavioral commitments. They would validate all models with frontline operators before deployment, maintain a consistent 4-week cycle from concept to initial implementation, and dedicate 25% of capacity to improving existing solutions rather than creating new ones. These simple principles guided hundreds of decisions across dozens of projects, creating a consistent pattern that delivered measurable competitive advantage. Strategic thinking for small data science teams. Those simple behavioral patterns created measurable advantage for large organizations. But what about the small data science team of just 3 people who told me they were too small to need a strategy? They later discovered something surprising. Strategic thinking becomes more critical as team size decreases, not less. Small data science teams face constraints that make strategic thinking seem like a luxury. When you're a team of 2 to 5 people, you're constantly juggling immediate deliverables while wearing multiple hats. One day you're building models, the next you're presenting to executives, and the day after you're troubleshooting infrastructure issues. The pressure to deliver quick wins is relentless, with stakeholders expecting results despite your limited resources. The typical small team operates in perpetual reactive mode. A marketing request comes in Monday, followed by a finance priority on Tuesday. Then the CEO sends an urgent request Wednesday that supersedes everything else. With no bandwidth buffer, each new request creates a ripple effect that disrupts previous commitments. This constant context switching severely limits productivity and makes focused work nearly impossible. When I suggested strategic thinking to a 4-person analytics team at a mid-sized retailer, their leader laughed. "We barely have time to finish our dashboards, much less develop a formal strategy document." His perspective made perfect sense. Formal strategy processes can be time-consuming, but this fundamentally misunderstands what strategy really entails for small teams. The paradox is that these very constraints make strategic thinking not a luxury, but an absolute necessity. With severely limited resources, small teams simply cannot afford to waste time on initiatives that don't create meaningful competitive advantage. They lack the buffer that larger teams have to absorb misdirected efforts or failed experiments. Every hour spent on the wrong priority is disproportionately costly. A strategic approach for small teams doesn't require elaborate documentation or formal processes. Instead, it needs only a clear understanding of how the team will behave to create competitive advantage, documented in the simplest possible format. The retail team eventually created a single-page document with 3 behavioral commitments that transformed their effectiveness. This lightweight approach emphasized clear decision criteria rather than comprehensive planning. The retail team committed to 3 behaviors. They would only build analytics that directly impacted customer retention metrics. They would deliver initial results within 2 weeks of any project initiation, and they would allocate Friday afternoons to improving their data infrastructure. These simple guardrails allowed them to quickly evaluate incoming requests without lengthy meetings or analysis paralysis. The startup fintech team I worked with implemented what they called strategic triage, a 5-minute evaluation of any new request against 3 questions. Does this directly support our competitive differentiation in automated loan processing? Can we complete a valuable version within our 2-week work cycle? Will the solution scale beyond the immediate use case? Any request failing these tests was either declined or renegotiated. Small teams can implement strategic behavioral patterns without bureaucracy by focusing on clear decision criteria, shared knowledge-building habits, and simplified communication. The 3-person data science team at a property management company created a simple collaboration ritual, a 15-minute daily stand-up focused not on status updates but on decision alignment. Each team member would share one key decision they were facing and get rapid input from colleagues. This ensured consistent strategic behavior across their work. Another effective pattern comes from a 5-person healthcare analytics team who established strategy anchors, physical reminders of their core behavioral commitments. They posted 3 questions prominently in their workspace. Are we prioritizing clinical impact over technical elegance? Are we creating solutions nurses can use without training? Are we reducing, not adding, to clinician workload? These visible reminders helped maintain consistent behavior without formal processes. What's particularly powerful about these approaches is that they enable small teams to punch far above their weight class. The 3-person insurance analytics team I consulted with competed directly against competitors with 30-plus data scientists. By focusing all their efforts on a specific customer segment underserved by larger players and committing to weekly customer interviews, they created specialized solutions with remarkable market fit. Their behavioral commitment to deep customer understanding created leverage that larger teams spread across many initiatives couldn't match. Similarly, a 2-person data science team at a regional manufacturing company created disproportionate impact by focusing exclusively on production line efficiency. Rather than attempting comprehensive coverage of all potential analytics use cases, they identified the single highest leverage point in the business and directed all their work toward it. Their strategic commitment to depth over breadth allowed them to build solutions with profound business impact despite their tiny team size. Small teams should focus their strategic thinking on identifying these leverage points rather than attempting comprehensive coverage. The medical device startup I advised succeeded by focusing exclusively on enhancing their sales team's effectiveness, ignoring potentially valuable but secondary applications in operations and finance. Their strategic behavior pattern included a weekly leverage test that evaluated whether any current work was drifting away from their core focus area. One of the most challenging aspects for small teams is maintaining strategic consistency despite frequent priority shifts. The 4-person analytics team at a software company addressed this by creating a strategy contract with leadership. This simple document outlined their behavioral commitments and clarified that any priority shift requiring deviation from these commitments would trigger a formal review. This moved them from passive recipients of changing demands to active partners in strategic decisions. Another effective technique comes from a 3-person municipal government data team who established priority buffers, deliberately keeping 30% of their capacity unallocated to absorb inevitable urgent requests without derailing strategic work. This buffer wasn't idle time, but rather protected capacity that allowed them to maintain their core behavioral commitments even when urgent requests arrived. The 2-person team at an education technology startup maintained consistency through what they called strategic minimums, non-negotiable time allocations for their highest leverage activities. They committed to spending at least 25% of their time directly observing how teachers used their analytics products, regardless of other demands. This minimum viable strategic behavior ensured they maintained their competitive advantage in user-centered design, despite constant pressure to build new features. Behaviors that win, building your strategy. Strategic minimums establish a foundation, but they don't tell you which behaviors will actually win in your market. The most successful data science teams I've worked with don't just protect their time. They deliberately engineer behavioral patterns across 4 domains that their competitors consistently overlook. These patterns aren't universal templates, they're precision instruments calibrated to your specific competitive landscape. Understanding which specific behaviors to prioritize requires a clear-eyed assessment of your competitive context. What makes a behavior strategic isn't that it's good practice, it's that it creates disproportionate advantage in your particular situation. For example, a behavior like meeting with stakeholders weekly might be necessary hygiene in one context, but a genuine competitive advantage in another organization where competitors maintain distant relationships with business partners. The most effective data science strategies I've encountered organize behaviors into 4 fundamental categories that together form a comprehensive approach. The first category focuses on knowledge acquisition, how your team learns, shares information, and builds institutional memory. The second centers on decision-making, the processes, criteria, and cadence of choices your team makes. The third addresses stakeholder interaction, how you engage with partners, users, and leadership. The fourth encompasses your technical approach, the methods, tools, and standards that define your work. Let's examine specific winning behaviors within each category. For knowledge acquisition, a consumer packaged goods company I worked with committed to spending 10% of their time living with the data, directly examining raw data without intermediary dashboards. This behavior uncovered subtle patterns their competitors missed. A financial services firm instituted mandatory cross-pollination sessions where data scientists regularly rotated between product teams, preventing knowledge silos that plagued their industry peers. For decision-making behaviors, a retail analytics team established a kill criteria framework where projects were evaluated against predetermined failure conditions every 2 weeks. This prevented the resource drain of prolonged unsuccessful initiatives that their competitors experienced. A healthcare analytics organization implemented what they called parallel paths, always maintaining at least 2 competing approaches to significant problems until clear superiority emerged. This prevented premature commitment to suboptimal solutions. In stakeholder interaction, a manufacturing analytics team practiced embedded rotation, where data scientists spent 1 week per quarter working directly alongside factory personnel. This created intuitive understanding of operational realities that competitors with centralized teams lacked. A software company implemented pre-mortem workshops with stakeholders before starting projects, imagining potential failures and building shared risk ownership that competitive teams struggle to establish. For technical approach, a telecommunications data science team committed to maintaining what they called model twins, simpler, interpretable models alongside more complex ones. This balance between explainability and performance created trust with leadership that competitors couldn't match. A government agency analytics team standardized on specific modeling approaches within domains rather than chasing the latest algorithms, creating consistency that outperformed competitors using more advanced but less reliable techniques. The specific competitive advantage created varies dramatically by context. A behavior like conducting weekly user research might create massive advantage in a consumer-facing digital product company where competitors prioritize technical innovation over user feedback. That same behavior might create minimal advantage in industrial analytics, where domain expertise and system reliability matter more than user experience. To assess which behaviors will create competitive advantage in your specific situation, start by identifying your organization's strategic priorities and competitive landscape. If your organization competes on innovation speed, behaviors emphasizing rapid experimentation and lightweight implementation will create advantage. If it competes on precision and reliability, behaviors emphasizing thorough validation and systematic documentation will matter more. Next, honestly evaluate your competitors' behavioral patterns. The greatest advantage comes from strategic differentiation, deliberately choosing behaviors that contrast with competitive norms. If your competitors maintain strict separation between data scientists and business users, behavior like co-development with stakeholders might create disproportionate advantage. If they over-index on technical sophistication at the expense of implementation speed, a behavior like deployment within 2 weeks of approval might create more value. Document these behaviors in a simple, actionable strategy statement that team members can readily understand and apply. Effective strategy statements avoid vague aspirations like become data-driven in favor of specific behavioral commitments. A transportation analytics team I worked with documented their strategy in a single page with statements like, we will maintain no more than 3 active projects per data scientist. We will deploy models only after they've been shadowed in production for 2 weeks. And we will dedicate every Friday afternoon to improving our collective knowledge through teaching sessions. The strongest strategy statements include not just what you will do, but what you won't do. A retail analytics team explicitly committed to refusing requests for one-off analysis without clear connection to customer retention. This clarified priorities and prevented resource dispersion that competitors experienced. Test your selected behaviors against the 3 requirements we discussed earlier. For consistency, ask whether these behaviors can be maintained through market changes and leadership transitions. For coherence, verify that the behaviors complement rather than contradict each other. For alignment, confirm that these behaviors directly support your organization's broader competitive strategy. A technology company initially committed to both rapid prototyping and comprehensive testing. Before discovering these behaviors, created internal conflict. They refined their approach to focus on targeted testing of critical components, which maintained quality while enabling speed. A healthcare analytics team committed to behaviors optimized for innovative discovery, only to realize their organization competed primarily on operational reliability. By realigning their behaviors with this reality, they created significantly more value. The most powerful test comes from asking, if our competitors adopted these exact same behaviors, would we still have an advantage? If the answer is no, your behaviors aren't strategically differentiated enough. If yes, you've identified genuinely strategic commitments. The patterns that consistently lead to success aren't universal best practices. Their behaviors specifically match to your competitive context. The most successful data science teams commit to patterns in knowledge acquisition, decision-making, stakeholder interaction, and technical approach that create advantage in their specific situation. Each organization must develop its own unique combination based on honest assessment of organizational priorities and competitive landscape. Testing your strategy, plan or true strategy. Think your data science team has a solid strategy? Most organizations confidently say yes, until they apply this simple test that reveals they've actually created nothing more than a sophisticated plan. What separates true strategies from well-disguised task lists is a specific element that's missing in over 80% of strategy documents. After years of reviewing data science strategy documents across dozens of organizations, I've developed a straightforward test that can instantly determine whether you've created a genuine strategy or merely an elaborate plan disguised as one. This test has proven remarkably effective regardless of team size or industry context. The challenge with evaluating your own strategy is objectivity. When we invest weeks or months creating what we believe is a strategic document, we develop blind spots. We become attached to our creation and interpret ambiguity in favorable ways. This is why external strategy consultants exist. They provide the objective perspective we often lack, but you don't need an expensive consultant to evaluate your strategy. Instead, start with this fundamental question. Does your strategy document clearly articulate how your team will behave differently from competitors or alternative approaches to create a specific advantage? This seemingly simple question cuts to the heart of strategic thinking. If your document primarily lists what you'll do rather than how you'll behave to win, it's likely not a strategy at all. The test forces you to confront whether you've made genuine behavioral commitments that create differentiation and advantage. Let me walk you through how this test works in practice. Recently, I evaluated a strategy document from a mid-size insurance company's data science team. Their document initially appeared impressive. It contained detailed sections on technologies, methodologies, and even specific projects scheduled for implementation. But when I applied the test question, the document failed completely. It contained no clear statements about behavioral patterns that would differentiate their approach from competitors or create specific advantages. When I pointed this out, the team initially pushed back, arguing that their technology selections represented strategic choices. But upon deeper examination, they recognized that their choices were industry-standard approaches that created no competitive differentiation. Their document was essentially an implementation plan, not a strategy. Beyond the fundamental test question, I recommend applying these additional diagnostic questions to thoroughly evaluate your strategy. First, can your behavioral commitments remain stable if market conditions change dramatically? True strategic behaviors should remain valid even when the external environment shifts. If your strategy would need to be completely rewritten following a market disruption, it's likely too tactical. Second, do your commitments create tension by forcing difficult trade-offs? Effective strategies require saying no to legitimate opportunities. If your strategy allows you to pursue virtually any reasonable data science initiative, it lacks the necessary focus to create advantage. Third, would your competitors be uncomfortable or unwilling to adopt the same behavioral patterns? If your stated approach would be equally appealing to competitors, it likely lacks the differentiation necessary for competitive advantage. Fourth, can team members easily apply your strategy to make daily decisions without constantly seeking approval? Effective strategies provide clear decision criteria that can be applied consistently across the organization. Let's examine how these tests play out with real examples. A healthcare analytics team's strategy document stated they would leverage cutting-edge machine learning techniques to improve patient outcomes. This failed the test because it described a goal rather than specific behavioral patterns. When pressed, The team couldn't articulate how their approach differed from competitors or created advantage. By contrast, another healthcare organization's strategy passed the test with flying colors. Their document committed to conducting at least 5 clinical workflow observations per month before developing any patient-facing analytics. This behavioral pattern created advantage by ensuring their solutions addressed actual clinical needs rather than assumed ones, something their competitors weren't systematically doing. Even more tellingly, when I tested this second healthcare team's strategy against market disruptions, it remained valid. When the pandemic dramatically altered healthcare delivery models, their commitment to workflow observation actually became more valuable, not less. They simply shifted from in-person observations to virtual ones while maintaining the core behavioral commitment. When organizations discover their strategy fails these tests, they typically exhibit one of 3 common gaps. The first is excessive focus on technical approaches rather than competitive behaviors. The second is a lack of clear trade-offs that force prioritization. The third is insufficient specificity about behavioral patterns, using vague statements like emphasize quality without defining what specific behaviors constitute that emphasis. Addressing these gaps requires iterative refinement. Start by identifying the competitive advantages your team needs to create, then work backward to define the specific behavioral patterns that would generate those advantages. Test each behavioral commitment against the diagnostic questions, refining until you have a set of commitments that clearly pass the test. A technology company I worked with initially had a data science strategy focused entirely on implementing specific machine learning techniques across various business functions. When they applied the test, they realized this approach failed to differentiate them from competitors who had access to the same techniques. Through several iterations, they transformed their strategy to focus on behavioral commitments around rapid experimentations. Specifically, they committed to running at least 3 customer-facing experiments weekly and making go-no-go decisions within 24 hours of receiving results. This approach created advantage through speed and learning velocity that their more bureaucratic competitors couldn't match. The revision process typically requires 3 to 5 iterations before a strategy successfully passes all test questions. Don't be discouraged if your first attempt fails. This is normal and part of the development process. Each iteration should bring you closer to a true strategy, focused on behavioral patterns that create competitive advantage. Once you've successfully tested your strategy, document it concisely. The most effective data science strategies I've seen are rarely longer than 3 to 5 pages. They focus on clearly articulating behavioral commitments, decision criteria, and the competitive advantages these behaviors create. Lengthy technical appendices or detailed project plans may complement a strategy but should never substitute for clear behavioral commitments. Remember that strategy testing isn't a one-time exercise. Revisit your test questions quarterly to ensure your strategy continues to create the intended advantages and remains relevant as competitive landscapes evolve. This doesn't mean rewriting your strategy frequently. True strategic behaviors should remain stable over time, but rather confirming that your behavioral commitments continue to create differentiation and advantage. Aligning your strategy for success. With your strategy now battle-tested and refined, you face perhaps the most deceptive challenge in implementation: organizational alignment. Most data science leaders discover too late that their technically sound strategies are colliding with invisible organizational barriers, creating friction that can quietly undermine months of strategic work. This alignment challenge often emerges as a disconnect between what your team has committed to and what the organization is prepared to support. Consider what happened at a major automotive manufacturer, where the data science team developed a brilliant strategy focused on predictive maintenance. Their behavioral commitments included running continuous monitoring experiments and deploying models within 6-week cycles. Despite the strategy passing all technical tests, it faltered within months as manufacturing unit managers resisted integrating new systems into their operations, and IT governance committees imposed 9-month security review cycles. The fundamental issue wasn't the strategy itself, but its integration with the broader organization. Research from the MIT Sloan Management Review indicates that 78% of data initiatives fail not because of technology or talent limitations, but because of organizational and cultural factors. This statistic reveals the critical importance of alignment as the final but essential component of strategy implementation. Successful alignment requires managing three crucial organizational interfaces. The first is executive leadership, where alignment means ensuring your behavioral commitments directly address the competitive challenges they perceive. A pharmaceutical data science leader discovered this when her team's focus on accelerating clinical trial analysis seemed disconnected from leadership's primary concern about declining R&D productivity. By reframing their strategy to explicitly show how faster analysis would identify unpromising compounds earlier, saving millions in development costs, she secured enthusiastic executive support. Executive alignment techniques that work include regular strategy dialogues rather than one-time presentations. A financial services data science leader established quarterly review sessions with C-suite executives where he would present not just outcomes, but how specific behavioral commitments were creating competitive advantage. These sessions evolved from skeptical questioning to collaborative strategy refinement as executives began to see themselves as co-creators rather than just approvers. Another effective approach is creating a translator document that maps your strategic behavioral commitments to executive priorities. A healthcare analytics team created a one-page visualization showing how each of their strategic behaviors directly supported the CEO's three stated priorities. This visual aid became a powerful alignment tool that executives actually kept on their desks for reference. The second crucial interface is with partner teams, the groups whose cooperation you need to succeed. These typically include IT, product teams, business units, and sometimes compliance or legal departments. Alignment here requires understanding their incentives, constraints, and working styles. A retail data science team discovered that their commitment to rapid experimentation was constantly frustrated by the IT department's quarterly release schedule. Rather than battling against this constraint, they created a lightweight experimentation environment in collaboration with IT, allowing them to run customer-facing tests without disrupting production systems. This collaborative solution preserved their strategic behavior while respecting IT's legitimate concerns about system stability. For partner team alignment, joint working sessions are far more effective than formal handoffs. A manufacturing analytics team instituted monthly strategy alignment workshops where representatives from operations, engineering, and IT would work through practical implications of the data science team's behavioral commitments. These sessions revealed potential conflicts early and created shared ownership of solutions. Creating explicit interface agreements has also proven highly effective. An insurance data science team developed partnership charters with each major internal collaborator, documenting expectations, communication protocols, and escalation procedures. These agreements reduced friction and helped all parties understand how their success metrics interrelated. The third critical interface is within your own team, ensuring individual contributors understand and embrace the strategic behaviors. A study by Gallup found that only 27% of employees strongly agree that they believe in their company's values. For data science teams, this disconnect often appears as misalignment between stated strategic behaviors and daily work priorities. A telecommunications data science leader addressed this by redesigning performance metrics to directly reflect the team's strategic behaviors. If the strategy emphasized rapid experimentation, individual performance reviews highlighted experiment velocity and learning quality rather than just model accuracy. This alignment created powerful reinforcement of strategic behaviors throughout the organization. Team alignment also requires making strategic behaviors visible in daily work. A technology company's data science team integrated their behavioral commitments into project kickoff templates, stand-ups, and retrospectives. They started each meeting with the question, how is today's work advancing our strategic behaviors? This constant reinforcement transformed abstract commitments into practical daily choices. While establishing these alignments, you'll inevitably encounter resistance and blockers. The key is identifying them before they derail your strategy. Common alignment blockers include conflicting incentive structures, legacy governance processes, and competing priorities among stakeholders. To identify potential blockers, conduct a pre-mortem exercise where you imagine it's 1 year later and your strategy has failed due to alignment issues. What happened? A biotechnology data science team used this technique to identify that their commitment to rapid model deployment would conflict with the company's rigid validation protocols. By proactively addressing this with quality assurance teams, They developed a tiered validation approach that maintained necessary safeguards while enabling their strategic behaviors. Once identified, addressing blockers requires a combination of education, adaptation, and negotiation. Education means helping others understand the competitive rationale behind your strategic behaviors. Adaptation means modifying implementation details while preserving core behavioral commitments. Negotiation means finding compromise solutions that meet multiple needs. Perhaps most challenging is maintaining alignment as both your strategy and the organization evolve. A consumer goods company's data science team instituted quarterly alignment health checks where they systematically assessed the current state of alignment across all three interfaces. These structured reviews helped them spot emerging misalignments before they became problematic. Creating mechanisms for ongoing dialogue is essential. A healthcare analytics team established a strategy advisory council with representatives from across the organization. This forum provided regular opportunities to discuss how changing organizational priorities or market conditions might affect alignment with the data science strategy. Successful alignment also requires adapting communication styles to different audiences. When discussing strategy with executives, focus on competitive outcomes. With partner teams, emphasize collaborative workflows. With team members, connect strategic behaviors to professional growth and meaningful impact. Throughout this journey, we've transformed our understanding of data science strategy from a mere project plan to a commitment of behavioral patterns that create competitive advantage. This paradigm shift enables teams of any size to be more adaptable while maintaining strategic integrity. Your immediate task is straightforward yet profound. Examine your current approach using our strategic framework. Ask yourself whether your team has clear behavioral commitments that directly contribute to winning in your competitive context. Remember that strategy manifests through daily actions, not PowerPoint slides. The most successful data science teams, regardless of size or resources, are those who consistently embody their strategic behaviors, adapting tactics while maintaining their competitive positioning. The true power of strategy lies not in predicting the future, but in building a team that can thrive within it.